This is 4.3.4 electric circuits, applications of linear equations. So we're going to learn two types of electric circuits. Okay, the first one will be the RL circuit. The second will be the RC circuit. Okay, let's look at the first one, that is the RL circuit. Okay, so the RL circuit consists of a resistor with resistance of R ohm and inductor with inductance of L Henry, and electromotive force or the EMF from a battery or a generator produces a voltage of E volts and a current of I ampere at time t. According to Kirchhoff's law, the sum of voltage that drop across the inductor and resistor will be equal to the supply voltage, but your VL here is equal to the L di dt, and the VR here is equal to the RI. Hence, we're going to have these differential equations. So these differential equations, we're going to use it to model the current I at time t. Now let's just look at the first example. So you have a generator having EMF 80 watt is connected in series with inductors 2 Henry and resistor 10 ohm. If the switch K is closed at the time t, set up the differentials for currents and determine the current at time t. So let's just gather the information from this example. Okay, so first of all, let's just look at this 80 watt. So this 80 watt is actually your ET. So ET is equals to 80 watts. Okay, it says that, okay, you have inductors 2 Henry. So inductors, we're going to use the symbol L. So your L is equals to 2 Henry. And you have resistor 10 ohm. Okay, so the resistor 10 ohm is referred to your R. Okay, so your R is equals to the 10 ohms. Okay, and then it mentions that the switch K is closed at the time equal to 0. So if it mentions that the switch is closed at the time equal to 0, means that you have no current at that moment. So if we're talking about current, the symbol for the current will be the I. Okay, so the current at time equal to 0 will be equal to 0. Okay, it will be equal to 0 ampere. Okay, it's because that, okay, when we're talking about no currents, means that you have 0 current. All right, okay, so then we're gonna have this one. Okay, then let's just look at questions. The question asks us to set up a differentials for the currents and determine the current at time t. Okay, once we have gathered the information for this example, let's just begin to solve this example by using its differential equations. So this is what we have here. So let's just do the substitutions. Okay, so we're going to substitute your value of L. So your value of L is actually 2 Henry. So we have 2 with di dt. Okay, plus with the R is actually 10 ohms. Okay, and then you have the E here. The E is 80. Okay, this is actually the differential equation for the current. Okay, so we have managed to set up differential equations for the current. Okay, now the next step that you have to do is divide all of the terms that you see here with number 2. So then you're going to have this one, it will be di dt only. And then this is actually 5i, and then you have 40. Now compare what we have here with the differential equation, linear differential equations. Okay, so this is the linear differential equations. Okay, so if you look at the linear differential equations, the variable that we have in the linear differential equations is you actually have the variable of y and you have the variable of x. Okay, let's just compare with our current differential equations. So your current differential equations is actually another linear equation. It's actually linear equation, so because it is actually in the form of linear equation, it's just that it's having the variable I and t. Okay, let's just compare the positions of each variable. Okay, if you look at the positions of y in the general linear equations, okay, this is y here, but in current, it is actually I. Okay, so it means that okay, the positions of y is took over by the variable I. So right here will be I here. So we have I here. Okay, how about the x here? The x here is actually this position is actually took over by the variable t. So we're going to have here. Okay, we're going to have the t here. Okay, so by using the same concept, okay, you can modify this general form of linear equations. Then we're going to have this one. Okay, so it means that okay, you can see that okay, the y here is changed to the I. Okay, the y here you have changed to I. Okay, the x here you change to the t, the x here change to t, the x here all change to t. So this is actually a linear equation also. It's just that it is in the variable of x, in the variable of I and t together. Okay, now okay, if we compare this current linear equations and with this, okay, so you can very easy to identify what is the value of p and what is the value of q. Okay, so your value of pt is the one that is next to the I, the variable I, that is this one, that is 5. Okay, how about your qt? Your qt is actually 40. So then we're going to write it out. Okay, so we're going to have the pt is 5 and your qt is actually 40. Okay, let's just recall the next step that we could have in the linear equations. That is, you're going to identify your you're going to identify your integrating factors. Okay, so this is actually your integrating factor, but I guess we need to modify this one just so that we can solve these current differential equations. So recall back the things that we have here. Okay, so we're going to change the x to t. Okay, so we're going to change the x into the t. So we're going to have t here, t here. So therefore, we're going to have this one. So let's just use this one in order to solve our questions here. So then we have the integrating factors is equals to the e to the power pt dt. So you have e, pt here is actually 5. Okay, so you integrate 5. Okay, so you have 5. So this is our integrating factors. Okay, now the last step to solve the linear equations that is you're going to use this formula, that is y(if) equal to integration qx if dx. Okay, again we're going to modify this one just that we can use to solve our current differential equation problem. Okay, so your y here, okay, so you have to change your y here into the I. Okay, and I'm going to change the x here. I'm going to change the x here into the t. The x here change to the t, the x here change to t. Then we have this one. We're going to use this formula to solve. Okay, so then we have the if equals to qt if dt. Alright, okay, so means that we have managed to modify all the linear equations that we have here, just that we can use it to solve the differential equations for the currents. Okay, so now let's just do the substitution. Okay, let me use another color. Okay, to solve this one, so let me use the yellow color. Okay, so we have I multiply with the if. The if here is actually 5t. Okay, the qt here is actually 40. Okay, what is our if here? Our if is actually e to the power 5t and dt. Okay, let's integrate the right hand side. So if you integrate the right hand side, so you will have 40 e 5t divided by 5 plus c. Okay, this one you basically can simplify it. Okay, so 40 divided by 5 is actually give you 8. So you have 8 e to the power of 5t plus c. Now divide all of them with e to the power of 5t. So we will have 8e 5t divided by e to the power of 5t plus c e to the power of 5t. And simplify it. Okay, so if you simplify it, we have I equal to 8 plus c e minus 5t. t. Okay, let's just name it as equation number 1. And now we're going to find out what is the value of the c here. So that is through this information that is going to substitute your I0 equal to 0 into your equation number 1. So means that your current is actually 0. You have 8 here, and then you have C, E minus 5. Okay, the time here is actually 0. So you simplify it, you will have your C is actually minus 8. Okay, so substitute your C as minus 8 into your equation number 1. So you will have I equals to 8 minus 8 E minus 5T. Okay, so this is the mathematical equations, okay, for current at time t. Okay, so this is the one that we are looking for. Let's just look at the example 2. So you have 60-watt electromotive force is applied to an RL series circuit in which the inductance is 0.2 Henry and the resistance is 12 ohm. Find the current IT if I0 equal to 0 ampere. Determine the current as time approaches to infinity. Okay, so let's just gather the information from this example. So you have 60 watt. Okay, so that 60 watt is done for your ET. Okay, so this is your ET is equal to 60 watt. And then you have the inductance is 0.2 Henry. So the inductance is referred to your L. Okay, so you have your L is 0.2 Henry. And then you have your resistance. Resistance is your R. So your R is 12 ohm. And then the last information that we could gather from this example is your I0 equal to 0 ampere. So that is the one. Okay, let's just look at the questions of this example. The question asks us to find the current IT. Okay, so this is the one. And the last question that is determine the current as the time, okay, as the t approaches to infinity. So this one, mathematically, you can write it in this way. That is the limit of the time approaches to infinity. Okay, what is the current? The current is the simple I, the current. Okay, so there will be I current, the I time equal to a question mark. Okay, let's just solve this example by using its differential equations. So, okay, let's just do the substitution. So you have your L is actually 0.2. So you have 0.2 here with di dt plus with your R is actually 12 ohm. So you have 12I, okay, equals to your ET. Your ET is actually 60. Okay, now simplify this one. Okay, divide all of them with 0.2. So you have di dt plus with 60I equals to 300. And this is the differential equations. Okay, let's just compare with the things that obtained just now. Okay, so now you can notice what is your PT. Your PT is the one that is next to the variable I. So you have your PT that is actually 60. And your QT will be 300. So you have QT that is 300. Okay, now the next step is you will use this integrating factor formula. So you have your IF is equals to the E to the power of PT dt. So you have E PT. Okay, your PT is actually 60 dt. So integrate it, you have E 60t. Okay, now let's just use the last formula that we have here. You have I multiply with IF equals to Q the QT IF dt. So let's just substitute it. So you have IF is e to the power of 60t equals to the integrations of QT. QT is 300, and then you have your IF is e to the power of 60t dt. So you integrate the right hand side. So if you integrate the right hand side, so we're going to have 300 E 60T divided by 60, okay, plus T. Okay, let's just simplify the right hand side. If you simplify the right hand side, so basically you give you 5 E 60 T plus C. Okay, now divide all the terms that you have here with E power of 60T. Okay, so you have I equals to 5E60T divided by E60T plus CE60T. Okay, so simplify it, then you will have your I is actually equals to 5 plus C E minus 60T. Okay, let's just name it as equation number 1. So we're going to find out what is the value of C here. So through this one, so you're going to have to substitute your I0 equal to 0 into your equation number 1. So, okay, so we have your current is actually 0, so you have 5 plus C E negative 60 together with the time is 0. Then we're going to obtain your value of C is actually negative 5. So substitute your value of C negative 5 into your equation number 1. So then you have I 5 minus 5 E negative 60 T. Okay, so this is basically the mathematical equations for the current IT. Okay, so this is the mathematical equations for the current I. Okay, so then let's just look at the last thing that we need to figure out, that is the limit. Okay, so then we're going to have the limit. The time approaches to infinity. Okay, what is your current? Okay, so we're going to use this one. Okay, we're going to use this one. So we're going to substitute, okay, the t as the infinity into here. So you will have negative 60 multiply with the infinity, then you will have infinity also. So you have e negative infinity. So e negative infinity is actually give you a 0. So then you will have this is actually 0. Okay, and then okay, then you will have actually the answer is actually 5. Okay, now we come to the second electric circuits, that is the RC circuits. So for the RC circuits, it consists of a resistor with resistance of R ohm, a capacitor with capacitance of C farads, and electromotive force. According to Kirchhoff's law, the sum of voltages that drop across the resistor and the capacitor will be equal to the supply voltage. But the VR here is actually equal to R multiplied with I, and the VC here is equals to 1 over C multiplied with Q. But if you substitute these two into this equation, you're going to have this one. Okay, if you look at this equation does not look like a differential equation. Let's investigate the relationship between the current I and the charge Q. Okay, so they are having a relationship of I equal to dq dt. If you substitute the I here with this dq dt, then you have next line. So this is the differential equations that models the charge Q at time t. Now we come to the third example. So you have a RC circuit containing an electromotive force of 80 watts, a capacitor with capacitance 0.05 farads, and a resistor with resistance of 5 ohm. If the initial charge is 0 coulombs, find the charge as current at any time t. Okay, So let's just begin to extract some information from this example. So let's just, figure out what is our ET first. Okay, so the 80 watt is your ET. So you have your ET is 80 watt. And then you have a capacitor with capacitance of 0.05 farads. Okay, this is actually your C. So your C is actually 0.05 farads. And you have a resistor with resistance of 5 ohm. Okay, this is actually your R. So your R is actually 5 ohm. And then it says that the initial charge is 0 coulombs. Okay, initial charge, you're going to use the symbol of Q. Initial means that the time, at the time equal to 0, is 0 coulombs. Okay, it's 0 coulombs. Okay, and this is what we have. Okay, so let's just look at the questions. The question asks us to find the charge and the current at any time t. Okay, let's just solve this example 3 by the differential equations. So this is the differential equations that we have here. Okay, let's just substitute the value of r. So your value of r is actually 5. Okay, so we have 5 dq dt. Okay, plus with 1 over c. So you have 1 over c. Your c here is actually 0.05. Multiply with the q. Okay, equal to the e. Okay, the e is 80. Now simplify the 1 over 0.05. Okay, if you simplify it, so this is give you actually 20 q with 80. Okay, now divide all the terms that you have here with number 5. So you have dq dt, and this is actually 4q, and this is actually 60. Now compare the differential equations that we have here with the general form of the linear equations. So this is the linear equations. Okay, so in the general form of the linear equations, we have two variables, the variable y and the variable x. Okay, now let's just compare with our differential equations for the charge. So for the charge, okay, you will see the variable q and the variable t. Okay, let's just compare the positions of the each of the variable. So you can see that the variable y, okay, is actually took over by the q. Okay, the positions of the y is actually took over by the q. So you can write q here. We have the q here. Okay, and how about the x? Okay, for the x, okay, it's actually took over by the t. So the x is took over by the t. Okay, so by using the same concept, we're going to do the substitutions I'm going to have here. So this is actually the general form for the differential equations for the charge. Okay, so now this is the linear equation. Okay, just for the charge. Okay, so now we can compare. Okay, to get the value of the p. Okay, so the value of p will be the one that is next to the q. So the pt here is actually 4, and our q. Okay, our qt is actually 16, so you have your qt is actually 16. The next step is we need to identify our integrating factors. Okay, so the general form for the integrating factor, this is the formula, and you're going to apply the same concept. You're going to do substitutions. If you substitute you're going to change your x and the x here with the t, okay, with the variable t. So then we have the next line. So let's just use this one into here. So we have the integrating factors, that is E, PT. Okay, so your PT here is 4. So if you integrate this one, this is basically give you E 40. Okay, now then you're going to solve this differential equation by using this formula, but this is actually the general form. You have to modify this one just that we can use for the charge differential equations. Remember just now we mentioned that you have to change your y into the q. Okay, so you have to change your y into the q. Okay, and you have to change your x, okay, into the t. So you have the x here, so you change to the t. So you have x here, you have to change to the t. So we're going to use this one in order to solve our problem. So we already have here, so we're going to have the q if equals to qt if dt. Right? Okay, so now let's just do your substitutions. You know your IF is e to the power of 4t, and integrate, okay, qt is 16, your IF is e to the power of 4t dt. Okay, let's just integrate our right hand side. So if you integrate our right hand side, so this is basically give you 16 e4t divided by 4 plus c, and you can simplify this one. So if you simplify this one, we will have q e4t. This is actually 4 e4t plus c. Okay, now divide all the terms that you have here with e to the power of 4t. So we have q equals to 4 plus c e minus 4t. Okay, so let's name it as equation number 1. So you need to figure out your value of c, so that is through this information. So we substitute your q0 equal to 0 into your equation number 1. Okay, so means that your charge is actually 0. So then you have your c e minus 4. The t here is actually 0. So then you have your value of c is actually in terms of negative 4. Okay, so c is actually negative 4. Let's substitute your c as negative 4 into your equation number 1. So we're going to have q equal to 4 minus 4 e minus 4 t. Okay, so then this is actually the charge equations. That is the mathematical equations for the charge at any time t. Okay, so at any time t. Okay, now we have settled this one. Then we're going to find out this one. Okay, the currents at any time t. So how are we going to announce that the mathematical equations that could represent the current at any time t, that is true? The formula that we have just now, that is this one. So it says that, okay, your I is actually equal to dq dt. So it means that you're going to differentiate this one. So if you differentiate 4, it's basically give you 0. And how about the minus 4 e to the power of negative 4t? So if you differentiate this one, this basically give you minus 4 multiplied with minus 4, then you have 16, that is e negative 4t. Alright, so this is actually the mathematical equations for the current at any time t. Alright, so this is the answer for the example 3.